Yesterday we went over rationalizing numerators and denominators of radical expressions. I'd like to do a couple of these today to make sure that everyone understands these. First one I'd like to do is this one right here. This is number 3 on your sheet. What we had to do there was rationalize the numerator. Now, rationalize the denominator. We want to get rid of all the radicals that are in our denominator. In order to do this, we're going to have to multiply by 1. Now 1 will be the conjugate of the denominator, which would be 4 square roots of 5 plus 7 square roots of 2. This is what we are multiplying both numerator and denominator by, the conjugate, meaning the same two terms of what we're trying to rationalize with the opposite sign separating them. So what this becomes now is two multiplication problems. We know how to multiply. Just be careful. We multiply the first times the first. Coefficient. 6 times 4 is 24. Square root of 5 times square root of 5 is 5. So for the first term we have 24 times 5, which is 120. We multiply the honors. Well, 6 times 7 is 42 square roots of 10. The inners, we get negative 20 square roots of 10. If we add these, we get positive 22 square roots of 10. Last times the last. Negative times a positive is negative. 5 times 7 is 35. Square root of 2 times square root of 2 is 2. So for the last term, we have 35 times 2, which is 70, over. Denominator. 4 times 4 is 16. Square root of 5 times square root of 5 is 5. So we have 16 times 5, which is 80. Multiplying the last. We have a negative. 7 times 7 is 49. Times 2 is 98. And so there's our numerator, our denominator. Now, if we combine like terms here, for the numerator, we have 50 plus 22 square roots of 10 over a negative 18. Okay? Now, we want to see if we can simplify this fraction. Well, the numerator consists of two terms. In factoring a two-termer, our first question is there anything common that we can extract? And the answer is yes. We can take out a 2. So we have 2 times quantity, 25, plus 11 square roots of 10, all over negative. Well, I'm going to put the negative in front of the entire fraction. 18. Well, 18 is 2 times 9. Notice what happens here. The 2's cancel, and our answer is negative 25 plus 11 square roots of 10 all over 9. Okay? Any questions on that? Next one I'd like to do is this problem right here. Square root of x plus the square root of y over the square root of x minus the square root of y. I want to rationalize the numerator. Numerator. In other words, this is number 4 in group 2. I want to get rid of the radical numerator, so I'm going to multiply by 1. 1 will be the conjugate of the numerator over itself. So we'd have the square root of x minus the square root of y over itself. Now this problem is a lot easier than the preceding problem. A lot easier. If we take a look at our numerator, we have the square root of x times the square root of x is x. We don't have a middle term. We have made it so. We multiply the last. Square root of y times square root of y is y. So there's our numerator, x minus y. Now our denominator, a little FOIL. We multiply the first times the first, well that will be square root of x times square root of x is x. If we multiply the honors, we have negative the square root of xy. The inside, we get negative the square root of xy. If we add these up, we get negative 2 square roots of xy. We now multiply the last. The negative times the negative is positive. The square root of y times square root of y is y. And there we multiply the denominator. There are no terms we can combine. We're finished with the problem. This is the answer. Okay? All it is a series of multiplication. Let's go on. Now, if I give you this, if I say, hey, square root of 4, well, everybody in the class will say, hey, the square root of 4 is 2. Because what I'm asking for is what number times itself will give you 4. It's 2. Now I'm going to make one little change on that, just one little change. Let's suppose I have the square root of negative 4. The square root of negative 4. This is what number times itself will give you a negative 4. There isn't any, right? No number that multiplied by itself will give you a negative 4. None. Now, if you go through your arithmetic history, the first thing you learned how to work with were the natural numbers, the counting numbers. And you learn how to operate with them. 1, 2, 3. You learn how to add 2 counting numbers. And anytime you added 2 counting numbers, you came out with a counting number. And that was great. You multiplied. And anytime you multiplied 2 counting numbers, you came out with a counting number. 5 times 4 counting numbers. You came out with 20, which was a counting number. Then you went into division. You found out that anytime you divide 2 counting numbers, you didn't have to come out with a counting number. In other words, if you said 6 divided by 3, that's 2. That was a counting number. That was good. But if you went 3 divided by 6, that wasn't good. We didn't have any number. So we invented new numbers. We called them fractions or decimals. Same thing. We learned how to operate with those. Add, subtract, multiply, divide. Then we go into subtraction. And we find if you take 2 counting numbers, you don't have to come out with a counting number in subtraction. 6 minus 3, that's good. But what about 3 minus 6? Back then when you were working with numbers, they said you couldn't do it. And you couldn't with the number system you had. You had to extend it. And these were called a set of integers. Or assigned numbers, negative numbers. Seems like every time we're stuck, we invent new numbers. We're stuck. We have to invent new numbers. So I'm going to hit you with a definition. The square root of negative 1 is equal to I. And the reason we use I is because all the numbers we have up until this time are called real numbers. Every fraction, decimal, whole number, radicals, they were real numbers. So we have a new number system we're going to call it imaginaries. It's not really, it's there. But we call it imaginaries. The I stand for imaginaries. Now when you get into physics, electricity, they'll change that to a J, but it's the same thing. It is the square root of negative 1. So if I take a look at this particular problem, I have the square root of negative 4. Well, the square root of negative 4 is nothing but the square root of 4 times the square root of negative 1. But the square root of 4 is 2. The square root of negative 1 is I. So the square root of negative 4 is 2I. 2I. Seems complicated, but it's very, very trivial, as you'll find out. Suppose we have the square root of negative 25. What would the square root of negative 25 equal? 5I. See how nice and easy it is? 5I. Okay, I don't know how he got it, but we'll find out on this problem. Square root of negative 8. Square root of negative 8. Tim?
Negative 2i.
No, he said negative 2i. I didn't get that.
No.
Tony?
2i times the square root of 2.
Yeah. The only thing we're learning new now is that the square root of a negative 1 is I. So, automatically, anytime you take the square root of a negative, you can bring the I on. We have I square roots of 8. Square root of negative 1 is I. So now I have to simplify 8. Well, you know how to simplify 8. You break it up into prime factors. Look at the index. We can take a 2 out. We get 2i square roots of 2. Okay? One more. Let's suppose we have the square root of negative 18. What would be the square root of negative 18? You get something, Kath.
Yeah.
Oh, yeah.
3i, the square root of 2.
Very good. 3i square roots of 2. How do we get it? Automatically. Now remember, this is only the square root of a negative. The cube root of a negative is a negative number. But the square root is where you have i's. So we have I times the square root of 18. We simplify 18. We know how to do that. We get 3i square roots of 2. Now, in dealing with i's, I can never have an exponent greater than 1. Never. Let's show you why. We know that I is equal to square root of negative 1. So if I have I square is I times I. Everybody agree with that? Which is the square root of negative 1 times the square root of negative 1. What is the square root of negative 1 times the square root of negative 1? Negative 1. Remember, the square root of a times the square root of a is a, whatever a is. So this is negative 1, equal to the radicand. So I square is equal to negative 1. I square is a negative 1. That's all it is. So therefore, if I have I cubed, well, I cubed is nothing but I squared times I. But I squared is a negative 1, so we get negative 1 times I, which is negative I. So I cube and negative I are the same thing. I to the fourth. I to the fourth is going to equal I squared times I squared. But I squared, we say, is a negative 1 times a negative 1. Well, negative 1 times a negative 1 is a
1.
What is it?
1.
1. Sure, that's what you said, Mike. Negative times a negative is positive. 1 times 1 is 1. Okay? Suppose I have I to the 10th. What would I to the 10th equal? Okay? Help. Somebody. What is it?
1.
1? Wong?
Negative 1.
Negative 1? Well, it's one of those two, I'll tell you that. Let's find out which one. Anytime you have an even exponent for I, you know it has to be 1. Because you don't have any i's left over. You have all I squares. Whether it's positive 1 or negative 1 depends on how many I squares we have here. So I to the 10th, Tony, is how many I squares?
5.
5. We have I squared times I squared times I squared. But each of these I squares is a negative 1. So we have negative 1 times negative 1 times negative 1 times negative 1 times negative 1, which is negative 1. Sure. So anytime it's even, you're going to end up with 1. Question is, what is it going to be, plus or minus? Well, it depends on how many I squares you have. If you have an even number, it's 1. If you have an odd number, it's negative 1. In other words, if I ask you, what is the value of I to the 20th? Well, how many I squares are there? 10? It'd be positive 1. If I ask you for I to the 34th, it's going to be 1. Question is what? Positive or negative? How many I squares do we have? 17. Answer, negative 1. Let's suppose I have I to the 17th. It's definitely going to be an I. It's on. The question is, what? Positive or negative? Somebody. Positive. Very good. We ended up with I. How many I's did we get rid of?
1.
How many I's did we get rid of? How many did we still have to begin with? 17. We ended up with 1. How many did we get rid of? 16. We got rid of I to the 16th. I to the 16th is how many I squares? 8. That's even, plus I. Okay? If I have I to the 11th, I'm going to end up with I. Okay? So I got rid of I to the 10th, which is how many I squares? 5? Negative. That's simple. That's simple. Okay? I can never have an exponent greater than 1. I'd like to hit you with another definition now. Complex number is a number in the form of A plus BI, where A and B are real numbers. Complex number is a number in the form of A plus BI, where A and B are real numbers. Example, 3 plus 5i. This is a complex number. What is A in this problem? 3. And B is 5. B is 5, not 5i. B is a coefficient of I. So A is 3, B is 5. Okay? Question. Is that a complex number? Negative 2, negative 7i. Is that a complex number?
Not by definition.
Not by definition? Why isn't it by definition?
Because it just has positive numbers.
What did I say positive numbers? I says A and B must be real numbers. I didn't say positive.
In the form of A plus.
A plus BI, sure.
That's mine.
Sure it is. What's A? Negative 2. What's B? Negative 7. Is negative 2 and negative 7 real numbers?
Yeah.
Sure they are. All the numbers we had up until today were real numbers. So A is negative 2, B is negative 7. This is definitely a complex number. Is that a complex number? Is that a complex number? 3/4 plus 1/2 I. Help. Somebody. Anybody.
Yes.
Yes. Sure it is. What's A?
3/4.
3/4. And B is 1/2. That is a complex number. Suppose I have 7i. 7i. Is this a complex number?
Yes.
Yes. Sure is. What's A, Tony?
0.
0. This is nothing but 0 plus 7i. 0 is a real number. 7 is a real number. This is a complex number. Is that a complex number?
No.
No? Well, one time, Tony, you're wrong. This is nothing plus 2 plus 0i.
So in other words, everything's a complex number.
Yeah. This is, all real numbers are complex, but all complexes aren't real. The biggest number system we have is this new number system, the complex number system. If this represents the complex, then a subset
Would be real.
would be the set of reals. And a subset of the reals would be the fractions, the negatives, the decimals, but the largest set we have is the set of complex numbers. This is our largest number system. And it is a number system, so we're going to have to learn how to operate with this system. Now remember, when you got numbers, counting numbers, you learned how to operate. Then you got fractions, you learned. Then you came out with negative numbers, you learned how to operate. Well, we have complex numbers, so we're going to have to learn how to operate with them. Now, all operations in math are binary, meaning you can only operate with two numbers at a time, whether it's addition, multiplication. No matter what the operation is, only two numbers at a time. So I'm going to have two complex numbers. I'm going to say, hey, let A equal, let's see, 3 minus 7i. I'm going to let B equal 2 plus 5i. So I have two numbers, A and B. Now I want to go through the operations of these complex numbers. So the first thing we have is A plus B. A plus B. What would we get for A plus B? This. Mike, you have something. A plus B. What are you going to get?
You had
Good.
5 minus 2i.
That's it. A plus B. We combine like terms and we come out with Mike's answer, which is 5 minus 2i. Everyone know how to add complex numbers? Nothing to it. Let's go with A minus B. We're subtracting. Okay. Tim?
1 minus 12i.
1 minus 12i. Everybody agree with that? You should. A, well, that's 3 minus 7i, minus B. That means the opposite of B. We're subtracting. The opposite of 2 plus 5i is negative 2, negative 5i. We now combine like terms. We have 3, negative 2 is 1. We have a negative 7i, and negative 5i is a negative 12i. And there's subtraction. Nice, simple. A times B. Well, what that means is 3 minus 7i times 2 plus 5i. Well, what's the magic word there? FOIL. Oh, go ahead. Two plus 5i, yeah. Come on, nice. Okay, little FOIL. What do we get for an answer? Tony?
41 plus I.
Very good. 41 plus I. Let's see how we get it. If we FOIL these two, we come out with 6. We have a positive 15i and a negative 14i gives us a positive I. We multiply the last, that's negative. 7 times 5 is 35. I times I is I squared. This is what we get when we multiply. 6 plus I, negative 35i squared. But I told you, I can never have an exponent greater than 1. And we add. Very, very, very important. We're going to use it. I squared is a negative 1. So if we change that around, we have 6 plus I minus 35 times a negative 1. Or 6 plus I plus 35, which is 41 plus I. Now, we have an I square here. What effect does I square have on the term? What effect does I square have on the term?
Negates it.
It negates it. Sure. Now notice, it was negative 35i squared, but I squared is a negative 1, so it just changes the sign of the term, makes the term positive. Remember that. I squared just negates the term. Okay? Now lastly, a over b. And I like to do this one. A over b. This is 3 minus 7i over 2 plus 5i. Now we don't have division in terms of complex numbers, but what we have is that we're never allowed to have an I in the denominator. We got i's in the denominator. I have to get rid of it. Sure, how? That's what we're doing. We're rationalizing. That's the square root. We're rationalizing the denominator. How are we going to rationalize it? Well, we're going to have to multiply both top and bottom by the conjugate of the denominator. So that would be 2 minus 5i. This is what we're multiplying both numerator and denominator by. If I do it correctly, numerator, I have 6. I have a minus 14i and a minus 15i is a minus 29i. Oh, this one comes out so beautiful. Plus 35i squared all over 4 minus 25i squared. Now, what does I squared do? It negates the term. Negates the term. So this positive 35 now becomes a negative 35. This negative 25 becomes a positive 25. So for our numerator, we have negative 29 minus 29i all over